Hi, this is Dr. S and welcome to video 4 of my series on reaction rates for Year 13 A-Level Chemistry. In my previous video we looked at the rate constant and how to calculate it. There's a reminder of the calculation we did on the screen. We calculated the value of K, including its units, by getting the rate equation, rearranging and substituting some values in. This video will look at some more complicated examples and give you a chance to try and prove that you can do it yourself. Okay, so here is another example that we'll look at. So we have a reaction in which D and E make F. The order of D is second, the order of E is first. There's the concentrations and there's the rate. So if we want to calculate the rate constant, we first have to determine the rate equation. So rate equations always start rate equals K. Now I have concentration of my reagent, so concentration of D, second order, so I'm going to square it, and concentration of E. Then I need to rearrange for K. So K equals rate over concentration of D squared multiplied by concentration of E. Now I can substitute in my numbers. So K equals the rate, which is 0.015 over concentration of D, which is 0.5 squared, multiplied by concentration of E, which is 0.6. Okay, now if you run that through a calculator, you should get a value of 0.01. And that's the numerical value. We now need the units. So just like in the previous video, let's look at the units of each of the components of this equation here. The units of rate are moles per decimeter cubed per second. The units of concentration are moles per decimeter cubed. Now we have two moles per decimeter cubed terms here and another one here, so we have 3 on the bottom. Moles per decimeter cubed times by moles per decimeter cubed times by moles per decimeter cubed. So like on the previous video, we're looking at what we can cancel out. There's a moles per decimeter cubed on the top and there's one on the bottom. They can cancel out, leaving 2 concentration terms on the bottom. So we now need to do 2 things. We need to multiply these 2 terms together and we need to take it to the top. So let's multiply them together first. So if I keep my s to the minus 1 on the top, if I multiply moles per decimeter cubed by moles per decimeter cubed, I get moles squared decimeter to the minus 6. Now if I want to take that up to the top, I need to invert the indices. So that becomes moles to the minus 2 dm to the positive 6 s to the minus 1. And remembering that we, by convention, put the positive indices first, that means that the units for this are dm to the 6 moles to the minus 2 s to the minus 1. Okay, now you should be able to get familiar with how to calculate those units because that will come up a few times this year. However, there is, as is always good, there is a bit of a cheat sheet. Okay, so in previous videos we've referred to overall order. Remember that the overall order of a reaction is the sum of the individual orders of the reagents. So at A level we're likely to get overall orders of first, second, third, fourth. It is possible to go past that, but at A level it's unlikely. So what we can look at is what are the units of each type of overall order. Now they can differ. So the units of K in each case differ because there are different numbers of concentration terms. So in first overall order, the units of K are s to the minus 1. In overall order second, which is like the example I did on the previous video, the units of K are dm 3 mole to the minus 1 s to the minus 1. The example I just carried out was a third order overall, so that is dm to the 6 moles to the minus 2 s to the minus 1. And you might be able to start seeing the pattern. For a fourth overall order, it would be dm to the 9 moles to the minus 3 s to the minus 1. So what you should always look for is the fact that the index of the DM is a multiple of 3. So it should be 3 times as much as the index of the mole, and it should be the opposite. So mole to the -3, DM to the +9. Okay, I'm now going to give you 2 examples to have a go at yourself. So I'm going to put them on the screen, then I'd like you to pause the video, try and calculate the answers, work out the units, and then come back when you're ready. So there are 2 examples there. Okay, so let's look at the first one. Firstly, rate equation. Rate equals K, concentration of Z, concentration of Y, both first order. Rearrange for K. K equals rate over concentration of Z, concentration of Y. Substitute numbers. K equals 0.06 over 0.15 times by 0.20. And then numerical value, which should be 2 in this case. Then we work out the units. Well, it's the second order overall, so when you've gone through the process, you should have units of dm to the 3, moles to the -1, s to the -1. Okay, the second one. Firstly, rate equation. Rate equals K, concentration of W, concentration of U squared because it's second order, and we can ignore V because it's 0 order. Rearrange for K. Rate over concentration of W, concentration of U squared. Substitute in numbers. 0.0101 over 1.4 times by 1.2 squared. Now that comes out with a slightly complicated number. So the actual numerical answer you'll get on your calculator for this is 0.0050099. So we need to look at shortening that. So our data here are to 2 significant figures and here to 3. We should use the lowest number of significant figures. So I'm going to report this answer to 2 significant figures, which is 0.0050. And my units, it's third order overall, so it's dm6 moles to the -2, s to the -1. I hope that's helped you understand the rate constant and how to calculate it. In my next series of videos, we'll then look at how to determine the orders of reactions from experimental results. Okay, I'll see you then.